Hello everyone, Assalamu alaikum. I am Sat Kamal. I am basically from Noshindi, but currently I am staying in Dhaka. I have passed my SSC examination from NKM High School and Homes with a grade of GPA 5. I have passed my HSC examination from Abdul Qadir Mullah City College, cutting the same grade. Now I am pursuing BSc in Computer Science and Engineering in Daffodil International University. My presentation topic is logic gates and BCD adder. Now I am starting my presentation. Logic gates. What is a logic gate? A logic gate is an initialized or physical device implementing a Boolean function. A logical operation performed on one or more binary inputs that produces a single binary output. Actually, a logic gate is a device that acts as a building block for digital circuits. They perform basic logical functions that are fundamental to digital circuits. Most electronic devices we use today will have some form of logic gates in them. Types of logic gates. There are three types of logic gates: universal gates, primary gates, and secondary gates. Universal gates: NAND gate and NOR gate. Primary gates are AND gate, OR gate, and NOT gate. And the secondary gates are XOR, XNOR, NAND, and NOR gate. A universal gate is a gate that can implement any Boolean function without the need to use any other gate type. But the secondary gates can be derived from AND, OR, and NOT gates. As we know that NAND gate and NOR gate can be derived from AND, OR, and NOT gate, but NAND and NOR gates are being classified as universal logic gates also. AND gate. An AND gate is a logic gate having two or more inputs and a single output. An AND gate operates on logical multiplication rules. Here is the logic circuit of an AND gate. If we look at the truth table, we will see that in this gate, if either of the inputs is low, then the output is also low. If all the inputs are high, then the output will also high. OR gate. An OR gate is a logic gate having two or more inputs and a single output. An OR gate operates on logical addition rules. Here is the logic circuit of an OR gate. If we look at the truth table, we will see that in this gate, if either of the inputs is low or both are high, then the output is high. If all the inputs are low, then the output will also be low. NOT gate. A NOT gate is a logic gate having single input and single output. A NOT gate operates on logical negation on its input. The NOT gate is often called an inverter. Here is the logic circuit of an NOT gate. If we look at the truth table, we will see that if the input is true, then the output will be false. Similarly, a false input results in a true output. NAND gate. A NAND gate is equivalent to an inverted input OR gate. It is a logic gate which produces an output which is false only if all its inputs are true. Here is the logic circuit of a NAND gate. And if we look at the truth table, we will see that when all inputs are high, the output is low. And for rest of the cases, the output is high. NAND gate is called a universal gate because all three primary logic gates can be implemented by a NAND gate. Now we will see how we can implement all three gates by a NAND gate. Implementation of AND, OR, and NOT gate using universal NAND gate. Here we implemented NOT gate using NAND gate. We can recognize this as a NOT gate by saying that this gate has a single input and a single output. Here we implemented AND gate using NAND gate. We can justify the results by saying that we have two inputs and we have an output that operates on logical multiplication rules. And here we implemented OR gate using NAND gate. We can also justify it. Here we can see that we have taken two inputs and we have an output that operates on logical addition rules. So we can say that NAND gate is a universal logic gate. NOR gate. A NOR gate is equivalent to an inverted input AND gate. It is a logic gate which produces an output which is false only if all its inputs are true or either one of the input is true. Here is the logic circuit of NOR gate. If we look at the truth table, we can see that the output of a NOR gate is high when all the inputs are low. For the rest of the cases, the output is low. NOR gate is also a universal logic gate because we can implement AND, OR and NOT gate by using NOR gate. Now we will implement these gates. Implementation of AND, OR and NOT gate using universal NOR gate. Here we implemented NOT gate using NOR gate. We can say that because we have a single input and a single output that operates on the negation law. Here we implemented OR gate using NOR gate. We can see that we have taken two inputs and we have single output, and the output operates on logical addition rules. And at last we implemented AND gate using NOR gate. We can justify the gate also. Here we have taken two inputs and we have single output, and the output operates on logical multiplication rules. We know that AND gate operates on logical multiplication rules. So we can say that NOR gate is a universal gate because we can implement AND, OR and NOT gate using a NOR gate. XOR gate. The XOR gate is a two-input digital circuit that outputs a logical 1 if the two input values differ. It means that the XOR gate gives an high output only if its two inputs are dissimilar. Namely, if one of them is high and the other is low. Here is the logic circuit of an XOR gate. We denote the XOR operation using this symbol. If we look at the truth table, we can see that an XOR gate gives high output when the inputs are dissimilar. When the inputs are similar, the output is low. XOR gate is used extensively in error detection circuits, computational logic comparators, and arithmetic logic circuits. XNOR gate. The XNOR gate is a combination of XOR gate followed by an inverter. It means that the XNOR gate gives an high output only if its two inputs are same. Namely, if both of them is high or both of them are low. Here is the logic circuit of the XNOR gate. We denote the XNOR operation by this symbol. Now, if we look at the truth table, we can see that when the inputs are same, the output is high. But when the inputs are not same, the output is low. The XNOR logic gates are used in error detection circuits as well, which are to detect odd parity or even parity bits in digital data transmission circuits. Now I will discuss my second topic, BCD adder. What is a BCD adder? BCD adder refers to a 4-bit binary adder that can add two 4-bit words of BCD format. The maximum sum result of a BCD input adder can be 19. As maximum number in BCD is 9, maybe there will be a carry from previous stage also. 4 bits are needed to represent all BCD digits 0 to 9, but with 4 bits we can represent up to 16 values. The extra 6 values are not valid BCD digits. Whenever the sum result is greater than 9, it will not be in BCD and will require correction, and that is to add plus 6 to the result. Here is the truth table for BCD adder. The logic circuit that checks the necessary BCD correction can be derived by detecting the condition where the resulting binary sum is decimal 10 through 19. It can be done by considering the shown truth table, in which the function f is true when the digit is not a valid BCD digit. Then the f equal z3.z2 plus z3.z1. Hence, f is true when carry out is true or when the previous result of f is true. The correct equation with resulting 1 is f equal carry out plus z3.z2 plus z3.z1. BCD adder circuit. Here we have the BCD adder circuit. If the primary output is greater than 9, it means incorrect BCD. And if the output carry is 1, then we will add plus 6 with the result again. But if the primary output is correct and does not need correction, then the output carry will be 0 and the result will be just the same. Here we have the detection circuit, and the adjusting circuit or the correction circuit is here. If the output carry is 1, then plus 6 will be added to the result and we will have the correct BCD. On the other hand, if the output carry is 0, that means the existing result is in BCD, so plus 0 will be added to the existing result. That means the final result will be just the same as the existing result. Because we know that the range of correct BCD is 0 to 9. If the output carry is 1, then we will add plus 6 to the existing result and we will get the correct BCD. That's all for me. Thank you. Assalamu alaikum.